In this lesson, we want to solve linear equations, but first let's consider what it means to be a solution to an equation. So for 1/5 x is equal to negative 30, here I'm giving you two different choices. Here we have like 95 and negative 150. Are these solutions to the equation 1/5 x equals negative 30? And all it means is if you plug in 95 for x, for example, does it make the left side equal the right side? I don't think this is going to work, but just to see it, I have 1/5 and then x is equal to 95. Is that going to be equal to negative 30? So I'm just kind of like asking this as a question, is that true? So the only thing to do is simplify the left-hand side. So that's 95 divided by 5. That's 19. Does that equal negative 30? And of course the answer is no. I mean, I knew it wasn't going to work because 95 was positive, the other side is negative. I knew it was not going to work out, but this is one approach to take, is to like guess what the answer is and go from there. So now we have this other possibility of, well, what about negative 150? This already looks a little bit better. The number itself is negative. It might make the equation balance. So let's try it for this one. I have 1/5. Now I'm plugging in negative 150. And is that going to equal negative 30? So it's already looking better in terms of the sign. But let's see. Oh, yeah, this is going to work, right? So we divide both terms here by 5. 5 goes into itself once. It goes into 15 3 times, so it has to go in a total of 30 times here. This is negative 30 is equal to negative 30. So this is in fact true. So negative 150 is a solution to the equation. So here's one approach, just kind of like trying some numbers and see if you get a value that works. It's probably not the best approach to take, especially if your equation is relatively simple. So for example 2, I don't want to try to guess the answer to this equation. Like, there's a lot going on. I think it'll be easier just to simplify and then perhaps try to balance this equation into something that's easier to solve. As long as I do the same thing to both sides of an equation, I'll end up with an equivalent equation. So let's see, I'm just going to copy the equation down again. So that is 2 times 3x plus 2. Okay, then that's going to be subtracted by 3x and then minus 1. And we have negative 5x plus 1 after it. Just to make it a little bigger. Okay, I think what I'll do is start by, I'll simplify both sides. So on the left side, I can't combine the negative 3x and the minus 1, but I can distribute the 2 into the parentheses. In fact, on the right side of the equation, I can distribute the negative 5 into the parentheses as well. I'll do that and then maybe simplify with like terms. So on the left, 2 times 3x is 6x, and then 2 times a positive 2 is a positive 4. And I'll just copy down the 3x and the minus 1. And then on the right, I have negative 5x, but this time it's going to be minus 5 like this. So before I start adding and subtracting things to both sides, I think I'm going to gather like terms. So looking across here, I see I have a 6x and a minus 3x. I can combine that. Okay, right. I also have this positive 4 and this minus 1. So I'll combine those. We have 6x minus 3x is 3x. And then 4 minus 1 is 3. And on the other side, I have negative 5x minus 5. So nothing new here in what we've done before. It's like distributing, combining some like terms. But now I can go no further unless I do the same thing to both sides of my equation. So what the approach I'll take is, let's see, maybe I'll add 5x to both sides. And I'll compare it with like terms. If I do this, I've done the same thing to both sides of my equation. So whatever I end up with still has to be equal. 3x and a 5x is an 8x. Copy down the plus 3. The minus 5x and positive 5x gives me 0. And then I'm just left with this -5. Continuing, okay, now I see if I subtract this 3 from both sides, that's the same thing on both sides, so my resulting equation will still be equal. I'll have 8x, then I get 0 is equal to -8. And at this point, I mean, once you know a number that makes your expression true, that is going to be the solution. But I mean, just to be a little bit careful here, I think what I'll do is divide both sides by 8. You could divide both sides by any number you want other than 0, but I'm choosing 8 because it just happens to work out nicely. It's going to cancel the 8s here. This whole side is just going to give me a -1, and that's my solution. X is equal to -1. We could go back to the original equation and check. You might want to try that, but the main idea here is once you've simplified both sides as far as you can, you're left with just doing the same thing to both sides of the equation, either adding or subtracting, multiplying, dividing both sides by the same amount. For example 3, same idea. I want to solve this equation for x. What number makes the equation true? We could start maybe adding and subtracting things to both sides, but I just want to go over a trick that you can use if you come across an expression that has fractions in it. So a good idea would be to cancel all of the denominators. And a simple way to do this is to multiply both sides by the same number. And to do that, I'll look at the, well, let's see, we have a 2, a 5, another 5, and a 2. If you want to cancel the denominators of each fraction, I want to find the least common denominator. And here we're dealing with a 2 and a 5. So they're both prime, so it would have to be that the product of these two, 10, is going to be my least common denominator, or multiple if you just like to refer to it as that. That's the first number that both 2 and 5 multiply to. So it should cancel both of the denominators. So as my first step, I'm going to do the same thing to both sides of my equation. So I need parentheses here. And that same thing is to multiply both sides by 10, the least common denominator. So this brand new equation, it still is true that it's equal because all I did was multiply the entire left side and right side by 10. So it looks like a mess now, but here's the trick. I'm going to take this 10 and I'm going to distribute it to these two terms, and then I'll do the same thing on the right side. So it looks messy now, but I think it'll simplify nicely in our next step. So let's go there. So I'm actually going to write it out, but we have, well, it's 10 over 1 times x over 2. Then I get minus, here we have 10 over 1 times 1 over 5. So that's what it means to distribute 10 to both terms. I'm just setting it up as fractions. So maybe this is my next step, I should say. Okay, now this is going to be equal to, again, we have 10 over 1 times 3 over 5. And then we have minus 10 over 1 times x over 2. This choice of 10 should cancel each denominator nicely. And I can already see that that's going to work. 2 goes into itself once, and it goes into 10 5 times. 5 goes into itself once, but it goes into 10 twice. And the same thing on the other side. I get a 1 and a 2, followed by, here we have a 1 and a 5. So just being careful, I want to rewrite this entire equation. We have 5x minus 2, and this is equal to 6 minus 5x. So the equation we started with was pretty difficult, but this new one, there's no denominators. We can use the same stuff as last time where I'll add or subtract the same thing to both sides of my equation. You could even do it in one step if you'd like to, but I think what I'll do is in 2 steps. first I'll add 5x to both sides of my equation. I've done the same thing to both sides, so the new equation will be equal, but I have 10x minus 2 is equal to 6, and the other two terms cancel. I guess the last step now would be to add 2 to both sides, which leaves us with 10x is equal to 8. And now dividing both sides by 10 gives me my answer. By dividing both sides by 10, the left side is actually just x. And here, I guess I'll leave it as a fraction. You could use a decimal, like you could say that this is equal to 0.8 if you were to type that in your calculator. There's nothing wrong with that. If you were going to leave your answer as a fraction, well, let's see, there's a factor of 2 between 8 and 10, so that would be 5, this would be 4. So 4/5 would be an acceptable reduced answer as well. For the last example, here we have another equation, no fractions in it, but actually decimals this time. And if you don't like working with decimals, much like if you don't like working with fractions, there is a way to cancel decimals from your equation. So when I look across here, well, I see there's this 0.2, it's negative, I have a 0.7, and also this 0.3, negative 0.3. If you multiplied those three numbers by 10, it would change it to -2, 7, and -3, which would cancel the decimals completely from this equation. So that's going to be my first step. It's actually going to be a lot like the previous step. I'm just going to multiply both sides by 10 and just be very careful using the distributive property. So I think this one will get kind of messy, but same idea. I'm multiplying both sides by the same number. So let's write that out. Okay, 10. I'll use a bracket here and just copy down the left side. So that's -0.2. Then I have x plus 1. And then plus 0.7. I think the other side, the right side, will be easier, but let's see, that's going to be 10. Then I have -0.3, and then 2 minus x. So it looks messy, but this is still equal. I did the same thing to both sides. I multiplied the entire both sides by 10. So now I want to distribute this 10. And this is one gigantic term, and here's a second one. So really, this 10 gets multiplied. You could write it right in the front of this first expression, and then it goes to this 0.7. And on the right side, it's even easier. There's really nothing to distribute. There's nothing separated by a plus or minus after this very first term. So this 10 really just gets multiplied to this -0.3. So for our next line, since we have 10 times -0.2, we just get -2. And the x plus 1 copies along. Now when that 10 gets distributed to the 0.7, it's now just 7. So I've multiplied the left side. And like once you see how this trick works, you could just take each term and change the decimals into the numbers that you want, as long as you're moving the decimal the appropriate number of places. For the other side, we get -3, and we have 2 minus x. Okay. So now this problem looks like some of the previous ones we've done. What we're going to do is we'll distribute the -2, we'll distribute the -3, combine like terms, and maybe we'll have to add or subtract things to get x all by itself, but let's go through that. Okay. So distributing the -2, and also distributing the -3, we have -2x minus 2 plus 7. That is equal to -6, but now it's going to be plus 3x. Simplifying only on the left this time, we have -2x Now we have a positive 5 is equal to a negative 6 plus 3x. I can't simplify the left or right side any further, but to get x by itself, what I'll do is I'm going to add 2x to both sides. I want to try this out in one step, actually. You can add whatever you want to both sides as long as it's the same thing. So maybe at the same time, I'm also going to add 6. You can do 2, 3, 4, however many steps that you need to in order to get x all by itself. So now I can just like look across and say, okay, the negative 2x and positive 2x just give me 0, but the 6 and the 5 would give me an 11. And on the other side, here your negative 6 and positive 6 cancel, but you're left with a 5x. To get x all by itself, I'll divide both sides by 5. And then this is my final answer, which I'll write off to the left. X is equal to 11 over 5.